create this website, data.learning, where it collates data from different government departments, both federal and state departments, and it tries to bring them into a central place. So yeah, let's just go here. So I'm going to demonstrate searching for one data set here. I want to get a table which contains age, sex, population data. Everyone can see this, right? So like any website, you just key in the terms and then you search. You get the list of data sets. Population classified by place of birth, age and sex, census 2001, and so on. You get a list of data sets. So let's say we want to get to the first one. So the way the data organized in this website is, a set of data sets are put in a group called a catalog. So you can see that the catalog information here. Ministry of Home Affairs released this catalog, and this catalog will have a set of data sets. So there are 6 data sets in this web page, and there are some 6 pages. So about 6 into 6, some 36 data sets are present here, and you can download it. And so it is still not the best that I would have wanted from a open government website. The data formats are different. They don't do any cleanup or any sort of formatting or anything. So it's just raw data from the ministry or the department, wherever it is coming from. So in this catalog, seems we got Excel files, but other data sets are in CSV, some are in JSON, some are in some other format. Word documents. Yeah, so it has got the state, age group, different age groups, birthplace, and then the population. So what this basically gives us is the number of people who are staying in Nagaland but who are not from Nagaland. So people who are actually born in Uttar Pradesh and then they migrated to Nagaland. So one use case is if we get the data set for all the states, then we can maybe plot or explore interstate migration. So this is the demo part. So now I want to go back to the PPT. So I have just demoed this. You enter keywords, you click on the relevant search result, you have the catalog, you find the data set that you want. If you are lucky, you will probably find the data set that you are looking for right on the first page. If you are not, you need to scroll down. Okay, so the idea for the package is to simplify this access. Let's say I have an idea. I want to get power data. So I say power, generation, state, and I click enter, and I get data, a list of search results. So this data may be distributed across different catalogs, different data sets, right? So you may have to do this manually again and again. You keep on clicking search results, you keep on clicking data sets and explore and do that. So instead, if we can write few functions, so you can programmatically make a loop, get all the data sets that you need, and then you can explore at once. That's the basic idea of this package. Okay, so the name is ogdindiar. So it's not a good name, it's not a name that I come up with. So, but how you can remember this is Open Government Data, India and R. So OGD, India, R. It's available at this link. So if you guys use R, you can install this package using this command. So the main use cases are two. So one is to provide functions to search and download datasets. Another is a few datasets in data.gov.in contain API access to get data in JSON format. So if you have the API ID, then you can use fetch data function to get that data. And there are a couple of vignettes online which describe how this functionality is, so you can go through that. Okay.
What we can do is APIs are also available for.
Yeah, so there is an API if you already know the dataset ID. So not for searching or not for exploring the different catalogs, but once you got the dataset, there may be an ID which is given on the website. So then if you are again and again accessing that, maybe you can directly use that.
Okay, so in that web page only there I will get the ID of that.
Yeah, so request API, okay, there will be an ID here in this box if it is available. Most of the times it is not, but so if you got a website and you wanna if you don't want to download the data and keep it on a server, then you can, if you have the API, then you can real time get access from it. You can request API as well by clicking this button. You need to log in, and then they will add API access. Okay. So we are going to do the same thing that we have done manually on the computer via R. So you use the search for datasets function to write the search terms that you are interested in, and that's it. You run it. And for this particular search terms, we have got 18 observations. The format of the resultant value from this output is a data frame, a table basically with two columns, name and link. Name is the name of the catalog and link is the URL. And these are the results that we have got. Population classified by place order. This is the one that we have seen on the web page as well. So let's get all the list of datasets from this catalog, right? So you can use this function, get datasets from a catalog, and then give the link of the catalog that you want, and then specify. So the way, so you have so many different pages, right? You can limit the number of pages that you want to go through. If you want to go through all the pages, then just give a big number or put infinity. It will keep on going, accessing every page and give you all the list of datasets. Okay, so this is the format of the resultant value, name, granularity. So since this is census data, it's decadal, every 10 years. File size of the file, number of downloads, res ID is the API ID if it is present. This is the default link. CSV is if the CSV link is present. Excel, ODS is open office data format. XLS is the normal one. JSON, XML, and JSONP. Okay, so I have run this already, and we have got 6 data sets. India for the full overall summarized data set, Sikkim, Uttar Pradesh, Jammu and Kashmir, Bihar, and Delhi. I don't really have much. So we went through a catalog, we found the data sets. Now the next thing is to download the data set. So you can just use the download dataset function, give the URL, give the file path where you want to store it, and that's it. You got the dataset. So reading the dataset. So this is not a function from the package. R already has enough packages that give access that read very different formats. There is read CSV for reading CSVs, read Excel for Excel, and so on. Okay, so here since it's an Excel file, I use a read Excel package and then read Excel function from that package to read the function, read the data. And this is a format. So this is same as the one that we have just downloaded. We have got table name, state code, district, area, age group, birthplace, total percent, male, female, rural, urban, and so on. So as I said, one of the things here is to understand the migration patterns from this particular data set. For a simple exploration, just to showcase an idea. So this is for Delhi residents, top states for place of birth, excluding the home state of Delhi obviously. So as expected, the neighborhood states are the ones from which most of the people migrate from. Uttar Pradesh, Bihar, Haryana, and so on. So that's the main gist of it. So go play. If you want to use the package, I suggest following the catalog that we have just went through. Download all the data sets from that catalog, maybe do some analysis like migration patterns across different states so that you get an idea to get a feel for the package. And yeah, so if you are facing problems with the package, please create an issue on the GitHub page. If you have ideas for contribution, again file an issue, we can talk about it, we can make a PR request, pull request, and we can go through it. And yeah, that's about it. So I have analysis that I want to showcase. So a couple of months back, so I use this package to get population pyramid charts. The population pyramid chart is basically histogram of age groups for males and females. So this is what it is. This basically gives you an idea of distribution of age and at the same time differences between males and females. So R, Diva, yeah. So what I wanted to do basically was to understand one, how different states are on the age side, and another, how are the differences between male and female distribution. So this one gives you the age distribution for different states sorted by average age. So Meghalaya is the youngest state in India and Kerala is the oldest at 33. And you can also see the distribution. So as you go down, states are older, people are older. So the southern states, Kerala, Tamil Nadu, and the western, and a couple of states in the north, those are the older ones, and the younger ones are Meghalaya, Jharkhand, Uttar Pradesh, Bihar, and so on. And this one,
one made like you are not no honor.
this one.
Yeah.
Yeah, so it's a union territory, right? So I think there are too many males over there, but I think it's because of migration from nearby
The
places.
union Daman.
Daman and Diu. And this plot kind of tells you the difference between age, male and female proportion. So if you see long, big orange bars, which means females are more, and if you see blue bars, which means males are more. Ideally, you would want these bars to be small and very near, like this, like Odisha, ideally. But the general thing that you see across different countries is more females, more women. The proportion of women is higher on the late side, so like greater than 70, greater than 80. So that's okay if you find bigger orange bars on the right hand side. But if you are finding big blue bars on the left side in the young age, so that's a female infanticide or some other factor. Right? So Delhi is a case, Chandigarh, Maharashtra is also bad. Sorry? Yeah, you can. So I have graded here, like, yeah, you can come up with your own notes. Okay, so that's about it. And the code for that, just to showcase how to use the package. Okay. Okay, it's not usable. So get data sets from a catalog, do the catalog. I want all the data sets, so I have put infinity, and then extract the name of the state, and then some cleaning up. So this one had both census 2010 and 2001 and 2011 census. So I wanted to get the latest data set for each state, so I did that here. And once you have got the data set list, do an LF for loop, iteration basically. Go through each of the data sets, download it, and then plot it. That's it. Thank you. Any questions?
So this one you will download to your system or you are directly showing to them?
Download into it.
So what's the difference if you are directly accessing the data and showing it?
So you can't do plots. So there is no system that this website provides for you to do anything, right? It only gives you files. That's all. If you want to do anything on it, download your data set, read it, and do something on it.
Kind of analysis.
Yeah.
So it will download only the required data or
So
Whatever you want.
So you have data sets here, right? So what the one that you click on will download.
So you can search also. So that's the key terms you are given in the download data sets. In the code, you're actually giving the keywords.
So you search for the catalog first,
86 population is the keyword.
and then you get the list of data sets from that catalog, and then you download the data set from that catalog. 3 steps, simple. Yeah. So I have put the presentation code here, and the one that I have showed right now is also on GitHub.
So I'll share all the
I can share the
presentation
links.
links.
Yeah.
For this package, what you have used for web scraping basically?
Yeah. So there is a package called RRest. If you use R, if you use
Harvest, I know.
okay, so
They are
simple as that.
okay.
Yeah, if you use Python, I think there is beautiful soup. I think as far as I know, and you can use that.
You have used Harvest.
RRest. You can go through the package actually. It's very simple code. You get the data, and then you have CSS. You just get the data. File. We can talk about it later. I can show the code also. It's very simple. Some 100 lines of code. Nice. Any other one?
Packet can be used for what on different documents?
Just this website basically. So if you are interested in open data, if you are interested in exploring government data, then you use it. You can make changes to package, like pull requests are welcome, use file and issue. But at the same time, the usability kind of decreases, right? So this is a nice thing to do because data.gui.in contains many data sets. But if it's a one-time thing, you probably don't want to do it. It's just too much hassle for too little value.
you have like different kind of data sets that you want to search for, like medical data set, which you want to get for analysis directly.
Okay.
So, can you use this package to manage some medical data also?
Do you know where the data is? Like this content, header.gov.in contains also health indicators as well. Yeah.
So, we can take data from that.
Yeah. So yeah, it contains more data than you can actually think of. It actually contains a pretty good library, pretty good catalog.
So this one is it wrote based on this keeping in mind that gov the format.
Yeah.
It is meant for this name itself indicate. I think this
Yeah.
package is made for data.gov.
Exactly. Yeah.
So you cannot off the shelf use it for some other site.
Yeah. If you want to use it for other package,
Other
other
sites,
sites,
yeah.
you can probably take a look at this code to
And
see
then-
how you can understand the code and then use it on another.
Is there any other data sets which you can say available in your data?
No. Thanks.
Thank you, Simon. So how many of you are completely new to machine learning? Okay. How many of you have used machine learning in some extent? Okay, cool. So I'm going to start with the basics, basically what machine learning means and what kind of algorithms are possible. And we'll go in detail into linear regression. Is it visible for everyone? So we'll go in detail into linear regression, and we'll also look at the code to basically how to write your first linear regression machine learning algorithm on our data set. So that's what we're going to do. And so at any point, if I'm talking about or using any words which you are not familiar with, please feel free to stop me, and then probably we can discuss that. So ML India, so this group, basically the intention for us is to foster and catalyze the machine learning ecosystem inside India. We observed, or as you can already see, like lot of research papers get submitted from various countries, China, India, but the number of research papers that go from India are really, really less. And we think the main reason is we don't have a very a community kind of a structure in India which enables more and more people to learn machine learning and pursue it. So this is the initiative that we are taking it. So yeah, this is the agenda. We'll have introduction to ML and then ML algorithms, linear regression, and then we'll have the workshop and discussion. So, what is machine learning? Like, if you see this definition by Herbert Simon, he says learning is any process by which system improves performance from experience. So this goes for any learning, like learning which happens with us, which happens with machines. It's a very generalized definition. In machine learning community, formally we use the definition by Tom Mitchell. It's considered as the modern definition of the machine learning. So what he says is a program is said to learn from experience E with respect to some class of task T and performance measured P if its performance in that task as measured by P improves with the experience. So in order to like understand this statement better, we can kind of like dissect it, right? Like what is the task that he's talking about? Let's take an example of playing chess. If we take that as task T, and experience is actually playing it over and over or playing it repeatedly, and performance measure here, let's say, is basically your chances of winning the game. So what this implies in respect to the playing the chess game is if you keep playing the chess over and over again and it leads to your improving in chances of winning the game, then we can say that there is a learning that is happening. So that's pretty much sums up like how machine learning is viewed in the current context. So we've been hearing machine learning, like it became kind of a buzzword in the recent years, more than in the past. The big reason for it is it's disrupting the AI right now. For that, there are two reasons. One is AI is artificial intelligence. It's basically like the sci-fi things that we see in the movies, where the agents are really intelligent or became artificially intelligent through some programming, right? Now, how is machine learning helping in doing that? And why the trend now is because we have more and more access to the lots of data right now, and the computing power of machines have really improved. So in the past 7 to 8 years, the computing power has improved so much that we are actually able to implement the neural networks and then actually benefit from implementing neural networks and kind of like helping the learning happen. So these two things, the increase in the computing power and availability of the data, led to the big trend of actually applying machine learning more and more these days. So it's already. Sorry. So machine learning is a way of enabling AI. So AI is a word which basically says that there is an artificial intelligence, right? Like the machine is artificially intelligent, right? How do you define intelligence here? It can be compared to like human intelligence. Are we talking about that level? Probably not, right? Like we can't imagine a machine to be as intelligent as human yet. But that's the whole theory of making a machine intelligence. But how do you do that is through machine learning. Machine learning is one of the ways which can enable the machines to be artificially intelligent.
AI is a bigger rule. AI is the biggest. ML is subset of that. We enable different use cases.
Yeah, AI is a more generic term.
Yeah,
AI
generic
uses a predefined algorithm, right? It doesn't learn from anything.
So AI is a generic term like that just gets thrown around easily. But ML is a more specific. It actually means some specified set of things. But AI in general means actually we want to go to artificial intelligence, like actual human.
It's a concept,
but
kind of.
yeah,
It's more of a concept. ML is the set of all the algorithms that we have developed, we have contributed in the past years to enable this kind of artificial intelligence. So it's already, so we are just starting on the ML, intro to ML workshop. So are you guys familiar with ML or is it like basic ML? Okay. So it's already widely used in our lives, like without even knowing us, like every time you check Facebook or every time you do a Google search, what you're using is machine learning algorithms behind the scenes. And
I have one just question. Assume a candidate is working in a ML, machine learning. I mean, it can be any data, like text data, voice data, video data, anything. So, can he say that he is a AI candidate? Is there any differentiation in that? Like what I just want to understand is, candidate is working on CV, computer vision, which is related to video and image processing. Using a machine learning algorithm. He can quote he can say that he is a artificial intelligence. I mean, is there any
So he is enabling the concept of the artificial intelligence through using ML. So yeah, he can say that, but that's a more of a generic term which is not really understood or doesn't give you any details on how you're doing it or how you're achieving it.
You can do, generally
Yeah,
you can say
technically
that.
you can do that, but
Yeah.
usually it doesn't give any details into like how.
Many companies also do that. So startup, it's kind of like a marketing product.
Apple City,
Getting the data science side. Data science,
Yes.
we will have a
You can say it is artificial intelligence.
He might be analyzing some data or something he might be analyzing. There also we use the machine learning a lot. So
Yeah.
that is a different skill. And the images,
Yeah, it's just you can say everything is in a broader sense, machine learning and AI. And people actually do that as well.
Personal assistants are AI, right? Personal assistants.
Yes.
Like Siri or
Yeah, you can call them AI agents.
they're AI. Or any bots or something.
Yes.
Bots.
So, just to have a little bit of difference, machine learning is only one way which can enable artificially intelligent agents, right? Like, they can be intelligent in many other ways as well. So, it's more a general. So this one is again important. If you look at a lot of machine learning algorithms, you would see it's highly you can actually use this chair. So it's really important to understand intuition. So along with all the mathematics, all the algorithms that you use, all the data you have, really to excel in machine learning, I think having an intuition is a really good skill. So this you will learn as you keep working on the ML problems. You know, like if you're stuck somewhere, like what to do next is more of intuition is not really a concept, but it's more like what do you think can be done next, or if it's happening in certain way, why do you think might happen in certain way, without actually going into the mathematics of it, but kind of like intuitively understanding. So these are some of the applications of ML. I would recommend to go see this TED talk, which basically talks about self-driving cars. So self-driving cars again is a really good application of ML. And in Facebook, if you're using Facebook, when you upload a photo, it automatically recognizes that it is you, and so that's Facebook auto tagging your photos. Again, the face recognition algorithms go into it. And so if you're using Siri, Cortana, or Google Now, or any other agents, you can see that there are a lot of machine learning algorithms which goes into it. Speech recognition is one of them. And then in the back, they might have a lot of relevance algos running. Personal recommendations, if you use Netflix or Amazon or Flipkart, when somebody is recommending you a product to buy or to watch, that's again machine learning algorithms. And then web search, if you're searching for something in Google or Bing, and then you get relevant results, right? Like the list of the results you get is basically after going through these multiple machine learning algorithms, the results you see is that. It goes through a lot of selection algorithms, relevance algorithms, there is a lot of filtering which happens based on the CTR. So all that happens, and then the final list you see is after all those. So broadly, ML algorithms can be broadly classified into two categories: supervised and unsupervised learning algorithms. So I would say broadly because there are other types of learning as well, like reinforcement learning, which comes somewhere between supervised and unsupervised, but we won't go into that today because it's really a little bit of high level and beyond the scope of it. So this diagram will help us understand how the supervised learning happens. Imagine you have a bunch of data with you. For example, it might be text, or it might be some documents or images, or it might be just the data with numbers, like the population data, or as Sainath was showing, the population of male, female. So all this kind of input data, we call it as the input data or the features. So sometimes we extract features out of this input data. Sometimes the input data itself acts as the features. And we have something called labels. Labels is the final value or the output. So for example, if I say, if I have a house of 1300 square feet and it has 4 bedrooms, I would say the price of that would be like 10 lakhs, say, right? So here the input data would be 1300 square feet and also the number of bedrooms, and the output data is the price. So we have this data, this we call as the training data. So the training data comprises of the list of all these features or the all the input values that we want to feed it, and we already know what is the output for those values. So this is called the labels. Labels are, it means that for this data there is already an output which is available. So we take these two things and then we feed it to a machine learning algorithms, and what comes out is a predictive model. So now what happens is, now the machine learning algorithm knows the input and also it knows the output, and it uses the techniques or the optimizations within the machine learning algorithm, and it outputs a predictive model which we call as hypothesis in machine learning. And so once we have the hypothesis ready, next what we can do is we can input it a new document which is very different or not present in the input set, and then we can input it to predictive model and it will predict the expected label. So this one it will predict for this new data input. So why is it called supervised? Because we are actually giving it what to learn. We are saying it, take this input, if this is the input, this is the output you get, learn from it, and then if I give you a new input, you should be able to predict what is the output for it. Okay? This is like how the supervised learning algorithms work. So, any questions here?
I think the new input that we are giving, it should be one of the inputs that we have given.
No, it can be completely new.
Then we may not get the accurate value.
No, that's how that's what machine learning does, right?
So that's what the model that we have created. Right? If we have a number of the more number of data that we have given while creating a model,
Yeah.
if the new data comes which is present in the train data set, we may get an accurate results. Otherwise, we may
No,
not.
but what is the use in creating a model if you just want to give it data from here? This output you already know, right? Like, it's not useful
It
here.
should come from the same population. The new data also should come from the
No,
same
no.
population.
Yeah, kind of. Not the same set. So
The same population.
Following the
sample.
same
Yeah.
underlying function should be good enough. But I mean, it depends really on how your algorithm is working on that data set.
In this case also should be in the same area. With different elements, the data also changes.
All these will depend upon the features.
so
Variant, they begin.
So the way not like that. Is there using a set of variables to make a model? So the same variable you should give for the model to predict. For example, in this case, area and square feet and number of bedrooms will be input variable.
No, so if it is not dependent on the area, say for example, in our input set, we didn't take, we only took the square feet and the number of bedrooms as the features, right? Suppose area is also one of the inputs. Say for example, Kormangala or Indiranagar or HSR. So these different areas, if it depends on the area of the house, then that should be fed as one of the input features or one of the input values. So the model actually learns for all those kind of features. So even now, if you give it in like a new area, it would be able to predict it, but you need to basically like keep into account how accurate it is, what is the precision recall and all.
That's one we can sort out using rankings. We can give rankings to our area.
No, actually, first thing is feature needs to be there. If whatever variables you want, it has to be there.
Yeah.
If other than those features, if you add something, most likely it will not give accurate result, and it's not the fault of the system also, because you have not told him what to do basically.
The algorithm has to be.
But
The algorithm has to be generic.
meaning, yeah, that's what you have to add it there, feed the data, then only it will learn. Otherwise, how it will learn? That's it.
Once we have made the algorithm, we want to change some of the features, like we want to include something new. So we need to change it in the algorithm first and then the data set, then we can get the accurate result.
You can add a new feature here.
In the feature vector itself, we can add a new feature.
Yeah.
So, but we didn't take the data set from that.
What do you mean?
Like,
So if you are adding a feature, I mean, you would expect that there is a data which would extract the feature out of it.
that should be there, right?
Yes, yes. So I think with this introduction we have come into like little bit of jargon that we use in machine learning is the features or the input data. There is basically this, the training set or the documents and images, and labels or observed values is this, the outputs that we already know. And cost function. We have this concept of cost function is, so if you go back, so once we give it the new data, the expected label here, right, or the predicted label here, let's say if it is like h of x, let's say it's called h of x. So this is what we predicted, but there can be an actual value for it, right? Like I gave a new input, like okay, I have 2 bedrooms, 500 square feet. Now feed it to the model. It gave me the price as 2 lakhs, but originally the price of that house can be 2.5 lakhs. So what is the difference between these two, and how do you how does that difference fall, and how do you minimize it? Is where the cost function comes into play.
We just move ahead. Yeah, we can stand up.
I think you,
Go ahead.
Go as ahead as possible.
cost function. We'll go into more details of cost function while we are doing linear regression, but the idea is basically once you have the model or the predictive model, you give it an input and then you get this expected output or the predicted output, right? So the cost function is the function of the differences of all the predicted outcomes and their actual outcomes. So what is the difference between the predicted outcomes and the actual outcomes? So the idea of cost function is we always have to minimize the cost function for the algorithm to be, like performing that.
So the actual outcome, how will you know?
You have the training set. Right? So this is the actual outcome. So this cost function minimization happens while training itself. So you have this input data, you have the actual output of it. You try to, like, with the model you have or with the training data you already used, you are trying to create a predictive model. And you are going to test it on the other data of the training set. At that time, you already know what the label is and you already know what your model is giving out. You can calculate the difference between them and then try to minimize that difference. So you have to keep training, you have to optimize the parameters more, you have to do more iterations. So those are the kind of feedback you get from actually looking at the cost function.
And once you define this predictive model, when a new existing comes, will it access this existing training or is completely disconnected? Once you are
So
done
this
with
model is generated based on the training set, right?
So once it is done, it won't access again. Access means when something new comes, new input comes.
No, it doesn't go and match it. It doesn't do that.
This is some new updates in the data set.
Sorry.
There is some new updates in the data set. As we know,
Yeah, you have to retrain your model.
So it will take once again the data set. You have to give the data set to it once again, right?
Yes.
For learning.
Yeah. You have to retrain it.
So, like, do we redo the algorithm or what? Redo the
No, if you
algorithm?
just have a change in data set, you're just going to take the new data and run the algorithm on it and create the new model.
That is the reason generally you try to generate a model as much data as you initially itself you take a bigger set of data, generate a model so that it works for almost all.
We can take data set, but the thing is, as we want data changes every day.
Yeah, definitely. I mean, in most of the companies, the training happens ongoing basis. As and when you get more and more data, right? Like for example, in Google or Bing, you will see that you get lot of search information or the click information, and continuously it gets feeded into data pipeline, and then finally you get your data set out of it, and then frequently or on ongoing basis for once in a month or bi-weekly, you would retrain your algorithm to fit in this new data that you actually captured. So that's
As soon as the update happens, we need to change our model.
So what do you mean by change in data? Meaning there can be two ways. One is change in feature, other can be just change of the data.
Update in the sense more data comes, like there is some new data. that
He's
is-
just talking about like more and more data, like
Okay, so I think then if not basically then it may not train itself. Meaning if you have taken sufficient data initially itself, features I can understand, then it will impact the algorithm.
No, it's not about more data. See, something like you are talking about flat price, right? It increases. So what will happen?
Simple example, you can, I can give a simple example on images. Images in the sense, assume I have categorized my data set. So 5 or 3 examples, like indoor, outdoor, portrait, all these things. Assume some highway data set has come to me. So my model is not going to work for that data.
Definitely not.
Yeah.
Will not work.
So we will have to include that data set and create a model.
Maybe
No, as like already that data is there. Like we have features. So as new new flags are available. So information about the new flags that has to be fitted and then only we can know about that.
It's not only there are databases.
new flag. Are you using it to get the output from the model,
Yes,
or
see, as we know, the properties changes. You are talking about an example of property. So earlier in my area, there were some 5 properties regarding what I was searching. Now, as they pass, there are some 2-4 properties more available. So will it be included in when we are searching? Will it be included or will it not be included? Will it be updated? So it depends on
I don't think you're talking about
It's
machine
not that
learning.
whether
Yeah,
you want to
here.
search for a flag or something. It's like based on data, you have some data. Like 2 BHK flats, this is the price range, 3 BHK flats, this is the price range. Now you want to train this algorithm and you want to say, okay, if I tell the new spec, this is my spec, this is the house I'm looking for, what will be the price? It will give me the price estimate. That's it. It is not a search application.
It is not a search engine. Like anything you want, you just don't want to feed it and then like kind of like be it there, right? So once we have this predictive model, it won't even like have access to this training data. It won't, once you ask the same example, it won't go and look up from here. Like it doesn't have any listings here. It's just going to learn some parameters from this data, and so that it can predict in the future or the next time somebody asks it a question.
So is that time gets reduced when, say, for example, the feature, for the first time we are including some features and doing this model, second time I'm changing some feature. So is that the time for first time it takes around 10 minutes to say whatever. So will it get reduced just if we add the features, or again the same time it takes to train itself?
It depends on like what or how you're computing the features, if you have done any optimizations, but usually I don't think the time changes. Yeah. If you add more and more, and if you add a lot of computation, your probably will take longer. Sometimes it can take, yeah, smaller. Any other questions? So the other terms that we see are the precision and recall. So usually we hear about like how accurate the algorithms are being, and we get some like 90%, 80%. So usually accuracy is not a really good term to basically understand what's going on in the machine learning algorithm. So we have these two terms, precision